Good evening, all. So now, in today's class, what we'll do is we'll try to solve 6 to 7 problems. Okay, so remaining 2 to 3 problems we'll solve in the next class. So the first problem. So you got an idea about hierarchical clustering, right? Any doubts in that? So anyway, we'll be solving it step by step, all the problems. Okay, so let us proceed. So the first problem is write a program to find the distance between 2 points. And here we are focused on Euclidean distance. Okay, so 2 points x1, y1, x2, y2 in a 2D space. So input would be 4 integers, and then the output consists of float value that corresponds to the distance between 2 points. Okay, so you have 0, 0, 1, 1, and the distance is 1.41. So this is quite a simple problem. So only thing is you have to take care of the validation part. So even like so a lot of prompt statements are there, right? Okay. So first statement is enter the first coordinate. So print. So this project completely, I will give you an overview and then I will solve all the problems. Next project and all, so what we can do is you'll have time, right, to practice. So in the next class, you can share your screen and then explain what a particular code is doing. So we can have a session like that for the next project. So and then x1, y1 for the first coordinate. So x1 is equal to int of input of. Okay, so you can give the branch statement here itself, right? So x1 colon slash n. Similarly, we can take y1 also. Y1 is equal to int of input of y1 slash n. So if you have any doubts in between, you can just stop me and ask for raise your doubts. No problem. So we have taken x1 and y1. Next, we are taking this coordinate of the second point. Enter the second coordinate. X2 is equal to int of input of x2, y2 is equal to int of input of y2. Done. So we have taken all the inputs. Now we have to find the distance. So we already know the distance formula is square root of x1 minus x to the whole square plus y1 minus y to the whole square. So if you want, you can do it step by step, or you can do it in a single step also. So here we're going to make use of square root function. Okay. So square root function is in math library. So first we want to use square root function. You have to import math library. So if you are confused with which library a particular function is there, you can just simply Google. You don't know what function to use also, you can Google. Okay, so just Google find square root in Python. So it will give the solution. So first link or second link will have the solution. See, have math dot square root. Fine. So math dot square root means you have to import math, right? So you have to import math here. And then, so distance, you can name it as D is equal to math dot square root of, okay, math dot square root of, here we have to give x1 minus x2 the whole square plus y1 minus y2 the whole square. So x1 minus x2 the whole square, we can use double star 2, okay, plus y1 minus y2 the whole square. That's all. So I use the formula and then we have found the square root. This distance is also calculated. And now it is given that it should be printed only 2 decimal points. Okay. So we can also use round function. The problem with the round function is that if we have only one decimal point, if you round up to two places, what happens is it will print only one decimal point. Okay. So round function will print if you want 2 decimal points, and if there is only one decimal point, suppose if you want to print 2.50, So round function will print only 2.5. The 0 will be like discarded because it is actually useless, right? Okay. So for that purpose, what we can do is we can use percentage point 2f. So print, we are printing the last statement, okay? Distance between 2 points is equal to percentage point 2f and then percentage d. That's all. Now I'll save the code, I'll execute the code. 0, 0, 1, 1. Distance is 1.41. So if you want, you can give a different input and test your code also. Validate. Okay, validation passed. And then now we can submit. Okay, got accepted. Any doubts, anyone?
No, sir.
Okay. So now we shall move to the next problem. In the previous problem, we found the distance in a 2D space. Now we're going to find the distance in the n-dimensional space. So write a program to find the distance between 2 points in a END, that is n-dimensional space. Okay. So here, all the inputs values are integers, and then output value, float value, that corresponds to the distance between 2 points in the ND space, and all floats should be displayed in 2 decimal points. So 2 decimal points. Okay. So first input is number of dimensions. So this is a variable, right? So there can be any number of x values, any number of, sorry, this is 0.1. Okay. So if based on the number of dimensions, it can have any number of values. Okay. And any number of y second coordinate also. First, let us take n from the user. So n is equal to int of input of enter the number of dimensions. Okay. Now n will be 4 will be stored in n. Now next we are going to take the coordinates. So we have first, this is point 1, right? Point 1 has 4 coordinates and point 2 has 4 coordinates. So how to take it? There are, it depends on n, right? So there are going to be multiple values. So we can create two lists. So P1, which will represent point 1, and which is going to be a list. Okay. So here we have these 4 values, right? 1, 1, 1, 1. All these things will be stored in the form of a list in P1. P2 is again a list. This 1, 2, 1, 2 will be stored in the form of a list in P2. Right? Now we're going to take the point 1. Enter the first coordinate. Now I need to take n number of values for point 1. So I have to use a for loop. Okay. For I in range of n. So now I will range from 0 to n minus 1, right? So if n is 4, then 0, 1, 2, 3. Range from 0 to 0, 1, 2, 3. Now here the values are 1. So I need to print x1, x2, x3, x4 for getting the input, right? So what I can do is I can straight away take the values and then append it to P1, right? Writing it down step by step. I can also do it step by step. Okay. I just take a temporary variable P is equal to int of input of. So here I want to print x1. So I have to do some formatting here, right? So because it is a varying strings. First I need to print x1, then I need to print x2, then x3, x4. So x percentage d percentage of here I plus 1, right? Because I is starting from 0, 1, 2, 3. Okay. So I take each and every input and then immediately append it to P on the corresponding P's. Okay. So first P1. So P1 dot append of P. Similarly, I can do for point 2 also. So print, enter the second coordinate. For I in range of n, again P is equal to int of input of here y, right? So I should print y here. Y percentage d percentage I plus 1. So P2, right? This P2 dot append of P. That's all. Okay. Now we have taken the points. So
Excuse me,
till this,
sir.
yes.
So, what is the objective of adding a percentage D and this over there?
Okay,
If
okay,
we, if
okay.
we don't do, then also it will give. I think I have even it comes with without that also.
So how did you do?
Sir, I have written X and colon and comma. Then I just gave I because in the range I have written from 1 to n plus 1 there. So I took it as I itself. Percentage I did not write.
Okay. So no, that also can be done. So here x comma, right?
Yes, I did.
X comma. So if you put comma, then automatically space will come. You have to put separator equal to null, all those things. No separator here, right? Because it's input.
No, sir, I want to know why. What is the objective of? I don't know what is point
Oh,
percentage
okay,
D.
okay, okay. No, in the first class we learned about this, right? This format specifier.
Yes, yes, yes.
The same thing. See, instead of if you want some integer to be replaced in this particular space,
Hmm.
I would percentage d. Are you asking about this percentage or this percentage d?
Both percentage
Both.
actually. Hmm.
Okay. See, actually, percentage d, percentage f, percentage s are all format specifiers.
Percentage F I know. D I think I forgot.
Okay, okay. So d is for integer. So in this particular location, an integer will be replaced. Okay.
Okay.
So here I plus 1 is an integer, right?
Yes, yes.
Okay. I is initially 0. So 0 plus 1 is 1. 1 will be replaced here.
Okay.
So like that for this loop, if I is 1, 1 plus 1 is 2. So 2 will be replaced.
It will
So we want
change.
x1, x2, x3, x4 for that purpose.
Okay. Thank you, sir.
Okay, no? Yeah. Similarly for here also, y also. Now we have P1, P2. Now we need to find out the distance. So here there are multiple points. In the previous problem, we had only two points. That is two coordinates. So we directly put x1 minus x2 plus a whole square plus y minus y to the whole square. But whereas here, we have to run a loop and then add all the elements. Okay. So D is equal to, initially I'll mark it as 0 for I in range of n. So here what we will do is p1 of 0 is the first coordinate, right? This has to be subtracted with p2 of 0 and then squared, right? Likewise, p1 of 1 should be subtracted with p2 of 1 and then squared. That is actually the distance from, right? Okay. So that is what we're going to do here. D plus equal to p1 of 0 minus p2 of, sorry, not 0, I,
D.
p2 of I, the whole square. Okay. So after the execution of this loop, you'll have the square values, some square values. After that, we need to take the square root. Again, for using square root, math. Either you can store it in a different variable or you can use same d itself. Okay, no problem. Because anyway, we're not going to use this d hereafter. So we can replace this d itself. D is equal to square root of d.
Math.
Okay, d is equal to square root of d.
Math dot.
Sorry?
Math dot square root of D.
Yeah, sorry. Math dot square root. Okay. Now print distance between 2 points is equal to, again, percentage 0.2f, comma, sorry, percentage d. That's all. Okay, save the code, execute. Yeah. So here I missed this slash in. Yeah. Now validation is successful. I can submit the code. Any doubts in this problem? Shall I move to the next problem?
Yes, sir.
Okay. No. So we need to find the minimum element. So given a matrix of size n cross n, write a program to find the minimum element in the matrix. Also print the row index and column index of the minimum element. So all inputs, values and output values are integers. Okay, everywhere are integers only. And yeah, so all these constants are given. No need to worry about that. And assume that no elements repeat. Duplicate elements are not there. Okay, fine. Now let us take the input and then do the process. First, we need to take the size of the matrix, which is n. Now we need to enter the elements of the matrix. So the print statement is there. So print. Okay. So I am creating a variable m, which is going to represent the matrix. And this is actually going to be a list of list. Okay. Initially, I created a list and I'm going to append all lists inside this matrix. Are you able to visualize? See, this is going to be a list and this is going to be another list. So list 1, list 2, list 3, list 4. And then what happens is all these lists will be appended to m. So it will be a list of list. Okay. Now, so here you can see that it is taken in a single line. All 4 values are taken in a single line. So I hope you remember this map function, which is used to convert this particular format to separate integers, and then it will create a list also to us. Okay, I'll show you the step here. And then here, so how many lines are there? 4 lines are there. Okay, which is nothing but the size of the matrix. So we need to run a loop for 4 times for I in range of n. Okay. So now I'll take a temporary variable which is going to hold the first list now. So once I convert this particular statement into a list, and then I'll append that list to m. Okay. So whatever input we take, it is going to come as a string only. No, that is what is Python's property. So we'll take this as a list, and then we split it, and then use map function to convert each and every value of that split to integer, and then we convert that to a list. Okay, so that is going to happen in a single step. So I'll show you that. So I'll show you step by step. First input. So this input will take this first line. Okay. So if you want, you can do it step by step also. I'll show you how to do it in a single line. So after that, you're using split function. Dot split. So what will this line do? It will give you each and every so it will split using space and then give 54 as a string, 87 as a string, 6 as a string, 23 as a string. So now we have 4 strings, okay, in a list. Okay, you have a list of 4 strings. Now for this, I'm going to apply the map function. Map of int comma. Okay, so we are going to apply this int function to all the values of this particular list. So it is nothing but int of 54, int of 87, int of 6, int of 23. So if we apply that, what happens? All the values which were strings will get converted to integers, right? So this map will return an object. So we need to convert it to a list. So that would be actually a map object. Okay. So if you want it in a form of a list, we can convert it to a list. If you want it in a form of a tuple, you can convert it to a tuple. If you want a set, convert it to a set. Like that, whatever you want, you can convert. Now I need a list, so I am converting to a list. Any doubts in this step? I hope you would have done this step, okay, already, but still I'm explaining.
No, sir.
Okay. So now T as a list, now I have to append this T to M. So M dot append of T. That's all. So you can even avoid one step by just putting M dot append of list of map of integer. That also you can do. If you're okay with that, you can do that. Okay. So now this M is containing all these elements in the form of a list of list. So we'll just visualize how is M looking like for I in M print of I. I'll just give a 3x3 matrix for simplicity. Okay. So this is what will be the content of M. Now I have to find the minimum element in the entire list. Okay. And since it is a two-dimensional structure, we can have the coordinates of each and every point, right? So if for one, the coordinate is 1, 2. So first row, second column. So like that we can do the iteration. So I need a minimum variable mi to store the minimum mi variable to store the minimum value, and initially I'll assign the first variable which is at 0 comma 0 as a minimum variable. So m of 0 of 0, and then I need to track the index also, right? I want to know what is the index also. So x is equal to, let x and y be the indices 0 and y is equal to 0. So whenever I find a new minimum value, I'll update this min as well as x and y. All these three variables I'm going to update. Okay. So now these for loops are going to be used to iterate over this matrix M. Whatever we have appended, I'm going to iterate over all the elements. Okay. So for I in M, and then for J in, okay, I need to track the index, right? So instead of putting here M, what I can do is I'll put range of M, range of N. Why? Because I and J will directly represent the coordinate values. I need not again find the index. Those complications I need not do. Directly I and J will be representing the index values. So for that purpose, I am putting like this. So I and J are going to correspond to the coordinates. Okay. Now if the current value at I comma j, if it is less than the previous mi, I will update mi x and y. Okay. So if mi, okay, we can just put m of I of j. If it is less than mi, what I should do? I should update this mi to, mi to this value, m of I of j. And after that, I have the new x and y value, right? So these ij values are going to be the new xi values. So x is equal to I and y is equal to j. That's all. Now we have to print the values. That's all. Whatever you have calculated, that those things you are going to print. Print the minimum element is comma mi. So here all integers only. No, we did not do any formatting. Percentage d, percentage f and all not needed. Directly you can put comma and then print it. Also we have a space here. So here we will be using percentage. Okay. If you don't use percentage, again I have to use some separator parameter and all I have to use. So instead of that, I can use percentage d. Print of row percentage d percentage x. Print column percentage d comma y. That's all.
Percentile y.
Oh, sorry. Minimum element is 1 and then row column is 1 comma 1. Okay. Pass. I can submit. Any doubts in this problem?
No, sir.
Okay. Next problem. So in this problem, we're going to find the block average. So last class I told you what is block and all those things, right? See here, given a matrix of size n cross n, write a program to find the average of all non-overlapping d cross d blocks. Okay, in a matrix and display the values. If a d cross d block cannot be formed, append additional zeros and find the average. So here, the size of the matrix is 5 cross 5 matrix, and then you can see the block size is 2. So here a 2 cross 2 matrix, 2 cross 2 matrix, sub matrices are taken, and then for all those things you are finding the average. Okay. Now at the last line you can see that there is only one row, and then what they're doing is they're appending two zeros here. So 4 0 12 0, that will be the submatrix that will be considered. Like you see here also 3 0 9 0 will be considered. And at this particular location, what happens? So at last we have to add a 0, and after that this will be considered as 7 0 0 0. Okay. So now let us solve the problem. First we need to get the number of elements. Sorry, first the matrix size. And then the block size. And then we are going to take the matrix elements. So taking the matrix elements is similar to the previous problem. So I'll do it quickly. M is equal to empty list for I in range of n, m dot append of list of map of int comma input dot split. That's all. So this will take all the values and store it in m. So till this point it is done. Now we have the block size and n. Using these two, can we find out whether 0 is needed or not? How to do that? That is 0 should be appended or not? How to find that?
If the size of matrix is divided by 2, then it need not require any zeros.
This will be d actually, right? D
In
can
n,
be any value. If
D,
n is divisible by d, yeah,
okay.
correct. So if n is divisible by d, then we need not add any zeros,
Yes.
right? Okay. So now we are going to find out how many zeros, how many rows and how many columns of zeros need to be added. That we're going to find out. So for that, here you can see, so here the size is 5, n is 5, and d is 2. So if you take modulo, what will you get?
2.5.
Modulo.
2.
2. Sorry.
Modulo, not division. Mod.
Okay. So 2.
No. Modulo.
Okay, remainder, no, so 3. 2 2s are 4, 1.
Remaining 1, right?
Yeah.
If you apply modulo, remaining 1 you will get. That 1 is nothing but, okay, so apart from dividing these dividing this matrix into D cross D, like a small D matrix. So finally you are left out with 1. That is what the remainder means, right? So like how many rows of zeros should be added?
1.
1.
1. How to find that 1?
N modulo D.
Reminders.
No. Remainder will give you how many, like apart from these perfect splits, how many is there will be given by modulo operation.
D minus N modulo D.
Yes, correct. So it is D minus N modulo D. See, for example, here, if N is, let us say it is 5 only, and if D is equal to 3, okay? So how many like zeros should be padded? How many rows of zeros should be padded?
1.
1, right? So whereas if you take N modulo D, what will you get? You will get
1.
2.
2, 2, 2. Yes.
Okay. So D minus N modulo D will give you the answer. Answer of how many zeros should be added. Okay. So what name shall we give? P. P for padding. Okay. P is equal to D minus N modulo D. Any doubts in this? Anyone? Understood now? We're just finding out how many zeros should be padded. Okay, with respect to row as well as with respect to column. Okay, so these many zeros need to be added for each sorry okay, so like these many zeros should be added for each row, right? See, suppose this gives 1, so in this row I have to add a 0. Again, in this row I have to add a 0. In this row I have to add a 0, right? And at last I'll add a single column, a single row with 6 zeros. That also I should do. Did you get this? In each row I have to append a 0. Okay. And at last, after doing this, finally I have to add a single row with all zeros. Okay. So let us see how to do that. Any doubts? Understandable, right?
Yes, sir.
Yes, sir.
Okay. So how many rows are there for I in range of n? Okay. And this I will do only if p is greater than 0. Okay. You can avoid these steps. If p is 0, what does it mean?
Need not to add any zeros.
Not add.
Yeah, correct. It is, we have a like perfect split can be done. So we need not add any zeros. Okay. So I equal to 0. Okay. For I in range of n. So either you can take a temporary list which will have zeros. See, I want to add a list of these many number of zeros. So if p is 4, okay, I have to add a list of 4 zeros. Append a list of 4 zeros, right? So what I'm doing is I'm using the repetition operator to create a list of p number of zeros. Any doubts in this step? So this will create a list of p number of zeros, right? Understood or not? Any doubts in this? Hello.
No, sir.
Okay. So here m of I will represent the corresponding list dot append of t. Okay. So this will run for n times, and then finally you will get what? the total the needed number of zeros appended at the last. Okay. Now what I should do is, so I should iterate p number of times, and then I have to add zero columns. Sorry, zeros. These many number of zeros as rows. Okay. For I in range of p. So t is equal to, so like I should create a list of how many zeros? N plus p, right? Did you get this? Should create a list of n plus p zeros into. Any doubts in this step? Do you understand what I'm doing here? This loop is used to create those many number of rows with zeros need to be padded. Okay. So how many zeros to be, that should be there in the list, which is nothing but n, which is the length of which is nothing but the size of the array plus p. Okay. And then here directly put m dot. Here it's not append. Okay, extend. Understood now why it is extend? See, if you put append, what happens? This list will be added as a single element at the end. Extend means it will extend these both. Whatever is there plus additionally zeros will be added. So here m dot append of p. Now padding is done. Okay. Now let us visualize the padded matrix. Okay. Hmm. I'll give 3, and the padding size, block size I want is 5. What is size? 5 cross 5 block. So what happens? So I have a 3 cross 3 matrix, and then in that I have to create a block of size 5 cross 5. So it means 2 columns and 2 rows will be added with zeros, right? Let us see. Okay, done. Understood till this point? Any doubts?
No, sir.
Okay. Now we have created the matrix. Now what we have to do? We have to take block by block and then find the average. So we can do hard coding itself. Not hard coding, like without using any inbuilt functions, we'll do it directly. So this will require 4 loops. Okay. I in range of. So this I is going to represent the row values, and j is going to represent column values, and the step size is going to be the block size. Okay, why? Because at one time I will be taking this entire block, and then I have to skip this, right? So I should not again contain 2, 2, 0, 2. So I should skip these 2 rows and then come to this particular column. So the step size is going to be the block size. Okay, 0, comma, n, comma, p. Similarly for j. Any doubts in this? Okay, so now what happens is this will take block by block. Okay, so first I will skip, like j will skip like this, and then column I will skip like this. Next will come here and then take a skip like this. And so once this is done, internally I have to run a loop for p cross p times. So each block is of p cross p size, right? I run a block for p cross p times, and then I will have to find the sum and then take the average. Okay. So for k in range of p, then for L in range of p. Then I'll take a temporary variable d is equal to 0. This is to calculate the sum of the numbers. So d plus equal to m of. So here I comma j is a block coordinate. Okay, this is 0 comma 0 block. This is 1 comma 1 0 comma 1 block, like that. So I plus k will give me, this will just iterate over this particular block alone. Okay, of j plus l. Understood this? So this particular loop, what it will do is, this will just iterate over this internal blocks. Okay, these blocks and all, p cross p blocks, it will iterate, and then it is taking all the sum values. So at the end of these two loops, d will be holding the sum of the particular block. And now I have to find the average. Okay, so average means what? How many elements are there in this block? Small blocks, how many elements are there? Yes, how many blocks are there?
9.
9. How 9?
2 blocks each. Two. I mean, 2 is to 2.
No,
1.
no. How many elements are there in each block?
Okay, 4.
4. How to find that 4? What is it 4?
D into D.
Hmm. Yeah, correct. So it is. Oh, I already taken D, no? Sorry. Should take some other value. Yes. So D is a block size, right? Okay. So yes. And then we can just update S itself. Okay. S is equal to S divided by D into D. Okay, fine. So this will give me the average. So I can directly print the average here itself. Okay, so or I can store it in a list and then print it, or I can directly print it here. Print the blockwise average is.
So once, can you repeat that for I in range p variable? Why did you use p?
Here.
I see.
Okay. See, so initially I is 0. Okay, so I is 0 and J is 0. So if I is 0, J is 0, I'll be processing this particular block. And after that, what should happen? I should not consider this 2, right? I should directly jump to this particular block. So the here, oh, not P, sorry, D.
It's D. It's D, I think,
Yeah, yeah, D.
because blocks.
Hmm. Now you understood, no?
Yes, sir.
Okay, so it will jump twice. So what happens? It will come over here and then it will process this block. Okay, so sorry for that. It is D cross D. Okay, and I can print the values. Print of. So I want 2 decimal points, right? So if I directly print yes, no, I will print some 6 to 7 decimal points, or only print um, whatever decimal point is there. So I'll use percentage point to F. Percentage. Yes. That's all. Yeah. So I got the output. Now we can remove additional print statements. Yes. Done. Any doubts in this problem?
No, sir.
Okay. Next problem. So write a program to convert a 1D array of size n into a matrix of size k cross k. For example, n equal to 4. Want to convert it to k cross k. Okay, and then this is the elements. So you can see that this 4 is going to be this n value is going to be a square value. Definitely is going to be a square value. Then only you can form uh, like we can be able to convert it to a form of a square, and then we can expand it to k cross k. Okay, so here n is 4. Okay, so what happens? These 4 elements are converted to 2 cross 2 format, and then this 2 cross 2 format is actually expanded like this. Okay, now let us solve it step by step. First, let us take n. Put off. Enter the n value, and then we can take a list. L is equal to these elements, and then print enter the values. For I in range of n, L dot append of int of input. Now we have taken the inputs, right? Next, let us take the k value. K is equal to int of input of enter the k value. Done. So all inputs are done. Now, first step is we need to find the square root of n. Okay. Let us name it as Sn is equal to math dot square root of n. So I want it to be an integer variable. Anyways, it will be integer. Square root will return float. Even if it is 2, it will return 2.0. Okay. So to just to make a round off, I'm just converting to integer. Okay. So now I got this like size of the small matrix. Okay. Now I have the size of the larger matrix, which is k. So I need a k cross k from 2 cross 2. From 2 cross 2, I want 8 cross 8. So each value should be expanded by a factor of what? K is 8. Okay, Sn is 2. Okay, so you can see that it is expanded by a factor of 4, right? So each one value is getting converted to a 4 cross 4 matrix. So how did we get that 4?
N.
No. And for this one, it's not 4. See, it is not n. See, like I'll explain again. See here, k is the larger matrix. Okay, and then n is the number of elements, and we have converted that n elements into, like, we are not converted, but we are considering that n elements to a smaller n cross n. Sorry, square root of n cross square root of n sized matrix. So it will be 1, 2, 3, 4. Okay, first line 1, 2, second line 3, 4. You have to imagine in that way. And that 1 is converted to a 4 cross 4 matrix with all ones. And then 2 is converted to all 2 cross 2. 4 cross 4 matrix with all 2s. So how come we'll get that 4? That is my question.
8 modulo square root of 4.
Sorry?
8 floor division with square root of 4.
Yes.
8 modulo divided by.
Divided.
Yeah, okay. So 8, there is nothing but k divided by Sn. That's all.
Yes, sir.
That will give you the size of each block. Okay, I'll just put D for block is equal to k divided by Sn. Okay, so now I need to create an 8 cross 8 matrix and I will fill the values using using the list. Okay, so M is equal to, I am going to create a matrix with all zeros. I need some dummy values to be filled, right? So let 0 be the dummy value for I in range of k. So there's going to be a k cross k zeros in this M. Understood? So here k is 8. So 8 cross 8 matrix with all zeros is going to be the matrix M. So first I need to create a list with 8 zeros, that is k zeros. And I will append it with M. Any doubts on this? I'm just creating a k cross k matrix with all zeros. Okay. Now I'm going to make the first 4, okay, first 4 cross 4 block as 1. So like what should be my values or iteration here? So here also block concept came, right? Okay. So we need to put 4 loops. No other go. For I in range of k, for j in range of k, not exactly k, it is actually 0 comma k comma block, 0 comma k comma block. Okay, fine. Now next what you're going to do is for, so we already taken k is already taken, l is also already taken, m, n, we have to see use o and p. Okay, o in range of b, p in, so range of b. So this is for block. Okay, and now what I'm going to do is I need to iterate over this l also, no? So for that I'll take some other variable q is equal to 0. And here this, the first block has to be filled with first element, which is a 0th element with respect to index. Okay, so m of I plus o of j plus p is equal to l of q. Okay, so that entire block should be put with l of q. Okay, l of q is nothing but q0 1. And after coming here, end of this two loops, I will increment q. That's it. Okay, now let us print m and c. 4 k values 8. Okay, so any doubts? Any doubts, anyone?
No doubt, sir. Sir, I want to
Yeah.
ask one thing that
Yes.
like the value of finding B and N. So you have taken directly, but I have taken in a little longer way, but I think it's the same answer. So is it necessary
Mm.
that we have to follow this only?
No, 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 no. You can follow your own logic. No problem. So we are, if you have a better logic, you can tell that also.
No, it's little longer. I think because
Okay.
I have taken position is equal to k square first, and
Okay.
then I took block is equal to under root of position divided by n. So
Mm-hmm.
it's longer. Its answer is coming same. I've checked for all three inputs, but
Mm-hmm.
I think yours one is shorter.
Okay, okay. Okay, you can use this one. Your logic if is working fine, then no problem. But so if you it is a suggestion as well. If you have a better concept or better idea, also you can suggest. No problem. Okay.
Okay, sir.
So here, okay, no brackets, no comma. We have to remove all those. So for j in I, print of j, comma, end is equal to space empty print. Okay, validate. Yes. Submit. Yeah. Okay. So we'll move on to the next problem. Okay. So now, given the features of n objects, write a program to compute the distance matrix. So we have n objects here. Okay. So we know distance matrix, right? So it is nothing but if there are three objects, you're going to find the distance between each and every object and fill this table. Okay. So this distance between object 0 and object 1 will be filled over here. Okay, distance between object 0 and object 2 will be filled over here. So like that, each and every coordinate will represent two objects, right? So this particular coordinate will represent second row, okay, that is second object and the first object. So it's the distance between the second object and the first object. Like that, each and every coordinate is going to represent each pair of objects. Okay, that is what we're going to fill it over here. Okay. Now, um, yeah. So all these are like two-dimensional points only. Okay, and then we have uh, first we are taking n number of points. Okay, so it means that it is a variable. There can be any number of points. So we have to involve list here. Okay, so what we can do is we can collect all x values and store it in one list, and we can collect all y values and store it in one list. Okay, why? Because the number of dimensions is known. If number of dimensions is also unknown, in that case we have to follow, okay, a list of list concept. Okay, fine, we'll go to that later. Now it is all two-dimensional list only. We know how many dimensions are there, so we need two lists, one dimension for x, sorry, one list for x, another list for y. Okay, first let us take the number of elements. N is equal to int of input of enter the number of points, and then enter the coordinates of point 1. So here, these are all going to be put inside the loop, right? Because how many times it's going to be iterated depends on this value again. So before that, let us create two lists. Okay, one list for x, another list for y. Okay, so for I in range of n. Now what we have to do? Enter the coordinate of point 1. Okay, so we can do it in print statement. Coordinates of point 1. So either you can do like this, or you can use percentage d also, whatever you want you can do, because here it's just integers, right? No need to format, and I'm using print statement. Okay, if it is input statement, then I have to use, I'll use percentage there. Okay, why? Because slash and all should come, that's why. Okay, fine. And now x1 should be printed, so print, sorry, input. So I will directly append it to x. Okay, so x dot append of int of input of x percentage d slash n, and then percentage of I plus 1. Any doubts in this? Similar to the second, third problem. That's it.
No.
And then y. So y dot append of int of input of y percentage d slash n percentage of I plus 1. So this will take all the inputs. So till this it is done. Next we need to find the distance matrix. So let us have the matrix M. Okay. And let us write a separate function for calculating the distance, because we want to do it multiple times, right? Okay. So even though it is going to be a single line, we can make it as a separate function. So let us assume that there's a function called calculate distance. We'll come to this later. Why? Because we'll finish off this main program and then we'll come back to the distance calculation. So how many elements are there? In this case, there are 9 elements, which is nothing but 3 into 3. So I have to run a loop for n cross n times. Okay. So for I in range of n, for j in range of n. Now here you can see that this I and j will act like coordinate values as well as the point representation also. See, this is the coordinate is 0, 1, right? Okay. So at 0th position of x and y, x of 0 is what? 0.1 x value. Y of 0 is 0.1 y value. So using this I and j itself, I can take the point wise values. Okay. So m of I okay. So I can take a separate. So I'm taking a separate list and then I'll append this list to m. Okay. So if you want to use m directly, then you have to create a matrix with the n cross n and append all zeros, all those things in do. Instead, we can append it in t and then after that we'll append t to m. Okay. So t dot append of, so calculate distance. Okay, calculate distance of, I'll pass x, y, I, j. So x and y coordinates are stored in these two lists, and then ij coordinate. I'm going to pass this 2 points. Okay, I point and j point. And now m dot append of t. Now let us come to distance calculation. So I'll pass x, y, I, j. Okay. Now either I can do it in a single step, or if you want to split it into multiple steps also you can do. I'll do it in a single step. Import math, return math dot square root of. So here x1 minus x2. Okay, is a formula, right? X1 minus x2. So how to take x1 and x2? There's nothing but ith value of list x and then the jth value of list x. Okay, that's it. Very simple. X of I minus x of j, the whole square. Okay, plus similarly for y of I minus y of j, the whole square. Understood? Any doubts in this? If you want, I can just take this step and put it here also. No problem. Any doubts?
No.
No, sir.
Okay. So now we have calculated all the distance values and then stored it in m. Now we have to print m. For I in of n, okay, sorry, I in m, for j in I, print. So two decimal spaces, all those things are needed. So percentage 0.2 f, comma, sorry, percentage j, okay, and then end is equal to space, print. Okay, done. Column is missing. Okay, the distance matrix is also need to be printed. Space also missing. Okay, okay. Any doubts? Understood this problem?
Yes, sir.
So it is just the distance between each and every point given, and then we are storing it. See, we have to actually optimize this. How to, you can just try coding in this way, okay? So why you have to optimize this is, see, all these calculations are going to repeat here also, okay? So if it is I comma j, j comma I value also is going to be the same. So we should not calculate it once again. Yeah, we should not calculate it once again. Okay, so you just include one more logic here. You just think and include one more logic, how to optimize that. Okay, okay, fine. So the next other three problems you can see in the next class. Okay, you can just give a try on the other three problems. We will solve the other three problems in the next class. Okay, fine. So shall we wind up?
Yes, sir.
Okay,
Thank you, sir.
yeah. Thank you all. Can meet in the next class.